This video is on benzene and aromaticity. As you may recall from a couple chapters back, if we mix bromine with cyclohexene, a bromonium ion will form and we will end up with the addition product dibromide. Why is this? Because alkenes react readily with bromine. However, if we take benzene and mix it with bromine, there will be no reaction. Why is this? There are 3 alkenes in a benzene. Why isn't it reacting? What about hydrogenation of styrene, this benzene with a vinyl group on it? We can readily hydrogenate the alkene outside of the benzene ring, but the benzene ring itself does not get reduced. What this is indicating is that the double bonds in the benzene ring are much more stable than the standalone alkenes. Why is this? It's because of resonance. These double bonds are practically whirling around in a circle, constantly resonating with each other, creating a much more stable structure. We refer to this as aromaticity, and the compounds that exhibit it are aromatic. We would say that aromatic compounds are stable because of resonance. However, just because they are more stable doesn't mean they are not reactive. If we modify the conditions to make them harsher, we can do the reactions that we expect. For example, if you take benzene with bromine and you add a strong Lewis acid such as aluminum bromide and heat, you will get bromination of the benzene. You can also hydrogenate styrene completely just to make ethyl cyclohexane if we increase the pressure and temperature with the hydrogen and nickel. You may be wondering, how much more stable is it? And we'll take a look. When you hydrogenate an alkene, heat is released. So if we hydrogenate, say, cyclohexene, we can measure the heat release, which turns out to be 120 kilojoules per mole. If the double bonds in benzene were regular alkenes, you would expect benzene to produce 360 kilojoules per mole, as it's 120 kilojoules per double bond. However, the complete hydrogenation of benzene only releases 208 kilojoules per mole. This difference of 152 kilojoules per mole can be termed as the resonance stabilization of benzene. If a compound is deemed to have resonance stabilization, it can be termed aromatic.